Hello, everyone. Hello.
Hello. Hello.
Yes, hope you can hear me. Can you see what I'm sharing?
Yes, we can see.
Okay, thank you. So we can proceed from here. And I can see everyone is in for the lesson. So we are going to start by reminding ourselves on what we covered in our previous lesson. And Purity, Silma, can you kindly remind us what we covered in the previous lesson?
Last lesson, we went through standard integration. That is the general rule of integration and how to integrate definite and indefinite integrals.
Okay, thank you very much. In our previous lesson, as she has said, we looked at the standard integration where we were able to look at the general rule of integration, and we are also able to look at the definite and indefinite integrals. So for today, we are going to look at another method of integration, that is integration by substitution. And before we start, we can go through the objectives of the session. Clivius, can you take us through this slide?
Yes, our learning outcomes for this lesson. By the end of the session, the learner should be able to define integration by substitution method, outline the steps involved in integration by substitution method, determine the integrals of algebraic functions.
Good. So those are the objectives of our today's session. And we are going to start by defining what we mean by the method of integration by substitution. And a volunteer can tell us what he or she understands by integration by substitution method. Jacob, can you tell us what you understand by the term integration by substitution method?
Yes, a trial. This is integration by letting another function to be integrated in the general integration function.
What we mean by integration by substitution method, and integration by substitution method means that it's a method of integration that involves replacing a variable within an integrand with a new variable to transform it into simpler form. With algebraic substitution, the substitution usually made is to let u be equal to f of x such that f of u is a standard integral. So we have different forms of integrals that we can integrate using this method. And if you have an integral that has been expressed in form with its derivative, and if you have the derivative of a function over the function itself, we can use this method of integration to substitute. This is like the opposite method of the chain rule method, which we looked in the differentiation. So this is like the chain rule in integration. So we are going to look at the steps involved in integration by substitution method, and a volunteer can kindly take us through this slide.
Okay, let me read.
Okay, Ian.
An appropriate substitution. Right, sorry.
Sorry for that.
Okay, first select an appropriate substitution. Number 2, write down substitution equation. Calculate the differential, the dx or dy in terms of the new variable. Express the integral in terms of a new variable. Integrate the resulting expression, and lastly, back substitution the original variable.
Okay, thank you very much, Ian. So these are the steps that are involved in integration by substitution method. So the first step is very key when we are integrating, because you have to choose the appropriate substitution whereby you'll be able to substitute all the variables in terms of the new variable. So we are going to have an example so that we can see how we can apply this method in integration. So we are going to evaluate the integral of 4x into x squared plus 5 cubed with respect to x. So someone kindly, can you tell us how we are going to select the appropriate substitution? What is going to be our u?
Okay, our u
Yes.
is going to be x squared plus 5.
Okay, thank you very much, Clivius. Our u will be x squared plus 5. So the next step, according to the previous slide, what are we supposed to do?
Differentiate that u function with respect to x.
Yes, thank you, Jacob. So the next step, we are supposed to write our substitution equation. That is u is equals to x squared plus 5. And now we can differentiate, as Jacob has already told us. So when we differentiate our equation, our new equation, with respect to x, what are we going to get? Ian. Ian, are we together? Someone can help Ian?
Okay. Well, when we differentiate u with respect to x,
Yes.
we'll get 2x.
Okay, thank you, Daisy. So when we differentiate our u, we are going to get 2x. So we are going to express our dx in terms of u. So when we express our dx in terms of u, we are going to have du over 2x. So from here, the next step, we are going to substitute our new variables. That is our u. And now we express also dx in terms of u in our original equation. So when we substitute, we are going to rewrite our equation as the integral of 4x into u cubed into du over 2x. So we can see here that 2x can cancel with 4x. What do we get when we divide 4x with 2x?
U cubed.
No,
2u cubed.
Yes, Daisy, yeah. We are going to have 2u cubed. And now when you look at our equation now, for our 2, it's our constant, so we can take it out of the integral sign. And we are going to have 2, the integral of u cubed du. So when you see at this, look at this equation. When you look at this equation, it's in the standard form as we learned in our previous lesson. So we are going to integrate this using the general rule of integration. So Jacob, when you integrate u cubed with respect to u, what do you get? Jacob, can you hear me?
Yes, so you are breaking.
Oh, sorry for that. I think I have some technical issue. I'm asking, what will you get when you integrate u cubed with respect to u?
Oh yes, you get u power 3 plus 1 divided by 4.
So good trial. When you integrate, remember we said that in our integration, we are supposed to add 1 to the power and then we divide. So we are going to add 1 into our power, that is 3. So we are going to get 4. So the answer will be 2 u power 4 over 4. And then don't forget the integral constant. And then after that, we are going to back substitute our original variables. So we are going to rewrite our equation in terms of x variables, whereby we are going to have, when we substitute, remember our u was x squared plus 5. That is, so we are going to have a half x squared plus 5 power 4 plus the integral constant. So this brings us to the end of our lesson, and I want a volunteer to tell us what we've learned. Someone can tell us what we've learned today? Clivius.
I've learned that to do integration by substitution,
Yes.
you first replace a variable
Yeah.
in one of the variable in the integrand to a new variable.
Yes. Okay, very good. So for us to use the substitution method, it's a method whereby we replace all the variables with the new variables. In our case, we were using u. So when we do the substitution, you must ensure that all the variables have been expressed in terms of u. So anyone with a question? So if there's no one with a question, here is an assignment for you. It's from our reference book, that is John Bird Engineering Mathematics. You're going to do exercise 174, page 443. And kindly ensure that you finish your assignment before our next session. Thank you very much and enjoy your evening.
You too.
Okay,
You too.
Okay,
Thank you, Mwalimu.
Yeah, you're welcome.